Hello everyone. The topic of today's lecture are going to be qualitative choice models. For this lecture, you will need certain R packages that you will need to install and activate before using in this lecture. You also need two files that you can download from Canvas and two additional files that are incorporated into the packages mlogit and AER. The first file, called fpdata.csv, and the second data, evdata.csv, can be downloaded from Canvas. The data sets called fishing and travel mode can be activated the following way in R. You type in data, then the name of the data set, the package it is associated with, and then you hit enter. Last time we talked about binary choice models. Binary choice models are used when the dependent variable or the outcome variable of interest can take one of two values, 0 or 1, basically answering a yes or no question. Did you vote during the last election? Did an individual recidivate after being released from prison? Does the person vote Democrat or Republican? In this lecture, we are going to expand on this concept to more than two categories. In the first part, we are going to look at what are called ordered logit models, when the dependent variable can be naturally ordered. For example, you can ask a person how happy they are, and they can tell you that they're either sad, okay, happy, or very happy. There's a natural ordering here, in the sense that very happy is ranked higher than happy, and happy is ranked higher than okay. In the second model that we are going to look at, called a multinomial logic, we are going to relax this assumption of natural ordering, in the sense that there is no ordering at all. If I ask people, how do you commute to campus, then it can be either, say, car, bus, walking, bike, etc. You can also extend that to the elections if you ask people whether they are voting Democrat, Republican, or Independent. There is no natural ordering in those questions. The term qualitative choice modeling comes from the agricultural economics or applied consumer research literature. For example, researchers are interested whether consumers are picking, say, beef, pork, or chicken based on certain attributes. Now, in the first part of this lecture, we are going to look at what is called an ordered logit model. And this slide is very technical, but let me explain to you what is going on here in a more graphical way. Suppose you ask people how much they consume of a certain good, or how often they purchase a particular good. Now, think about the purchase decision, or how often they purchase, as a linear step, and they can tell you that they are purchasing it either, say, daily, or they are purchasing something weekly. They can purchase something monthly, or they can purchase, say, something yearly. Okay? Now, suppose that we have two consumers, and one of them is either going to purchase it, say, every second day, and the second consumer is going to purchase it every third day. Then those consumers are both going to say, most likely, that they're purchasing it weekly. But we cannot differentiate between the purchasing it twice a week or purchasing it 3 times a week. Okay? What this is that the researcher only observes discrete categories, but does not observe the exact amount. In ordered logit models, what we are then going to do is we are calculating the probability that a person is purchasing it, for example, daily, based on certain independent variables. Okay. Now, this is very similar to the binary choice model, where this value here could only take two values, 0 or 1. Now, in this model, the dependent variable can take more than two values. But those values are actually naturally ordered. Okay. So what we assume as a researcher is that there's a certain latent variable y that we cannot observe. That would be the exact purchasing frequency. And the only thing the researcher observes is actually an interval. Okay. Now, how we are going to model this is that we are going to calculate cutoff points, and a particular consumer is going to fall, or a particular respondent is going to fall within those cutoff points. Okay. Now, to illustrate this concept, let us make an example with the purchasing frequency of organic tomatoes and organic strawberries. The data set is actually taken from a paper that a co-author and I have published a couple of years ago. In that paper, we ask consumers how often they purchase organic tomatoes and how often they purchase organic strawberries. Consumers had a choice to say never, rarely, once per month, every 2 weeks, once or twice per week, almost daily. In this case, we also have, or for this lecture, we are also going to have 3 independent variables. We are going to have age, female, and education. We will also have a dummy variable which indicates whether there are children under the age of 12 in the household. So let us have a look at the data set in R and also at the implementation of this model. Note that for the ordered logit model, as well as for the multinomial model, which we are going to see later, the most tedious part is to get the data into the right format. The interpretation is going to be very similar to what we have seen in the past. So for this exercise, I have already loaded all the data that we need. So the data that we are going to use in this exercise is called FP data. FP actually stands for frequency paper. This is how I called the paper, how I called the project. Now note that there are many other variables in the model, but what we are interested in right now is the variable strawberries underscore org. This is the purchase frequency of organic strawberries. And we are also interested in the demographics of whether the person is female, age of the respondent, and also if there are kids under 12 in the household. And note that we also have the education in here as well. So in the first step, to actually use R to calculate this model, we first have to make sure that the dependent variable in this case is the strawberries under dash org, is actually coded as a factor in R. So we write FP data underscore strawberries, FP data $ strawberries underscore org equals as factor. and then we hit enter. Now let us just extract the data that we need. Say, let's call it straw data equals FP data. And then we are just going to extract strawberries, age, education, female, and kids under 12. And then we are going to use a command that is called na-omit. Now what na-omit does is it deletes all the rows that are not complete. So in our case, we have initially 176 observations. And for example, we have observation 34, where we do not have information about the education of the respondent. After we apply the function na-omit, this observation is going to be eliminated. So now we are left with 173 respondents. Now, to estimate the model, we type in b hat, and we are using the command polr. Note that this command is associated with the package mass, and it fits an ordered logit model. So here we just say polr strawberries org tilde age education female kids under 12, and the data is straw data. And note that you have to type in Hess equals true. For those of you that are interested, Hess refers to a Hessian matrix, and it is used to actually estimate the model. If you think back about the numerical methods that I talked about for those type of models, this is simply a parameter that ensures that the model solves correctly. Then we hit enter. And we type in summary b hat, and we get our estimates. Note that this command does not give us the p-value to interpret the statistical significance of our model. However, we know from the normal distribution as well as the t-distribution that statistical significance occurs at a value of approximately 2. So in this case, we see that we only have age as a statistically significant coefficient or variable. Now here we have a negative sign. What this negative sign means is that the older the person, the less likely they are to be one of the high-frequency purchasers of organic strawberries. Think about this the following way. We are talking about people purchasing strawberries, and say we only have, say, never, rarely, and a lot. Now, a positive coefficient means that a person or a respondent is moving in this direction, meaning that if it's positive, they're actually increasing their purchase frequency of the dependent variable. Note that R also calculates the cutoff values between the various categories. So if you're thinking back about this graph here I had an example where the cutoff was at negative 1.5 and at 2. Now in this case, the cutoff values are at negative 1.49, negative 4.4, and so on. Note that usually those values are not very important. All we really care about are the values of the coefficients and the t-value to determine whether they are statistically significant. Now, very much like the binary choice model, meaning the probit or the logit model, we can only interpret the sign of those coefficients, but we cannot interpret the coefficients themselves. To do so, we actually need to calculate the marginal effects. And to calculate the marginal effects, we type in x equals small o, small c, then large M, large E. This is a command associated with the package ER. And we type in b hat. And then we type in x, $out, $all. We are picking the marginal effects of all. Now, remember that age was associated with a negative coefficient. What this means is that if age increases, the probability of being in one of the high categories or one of the high purchase frequency categories decreases. Now, if you're looking here at the marginal effects, so the 0, 1, 2, 3, 4, and 5 refers to the purchase frequency. So here we have the category never, rarely, once or twice a week, and so on. Okay, this is something you can find on the slides. Now, if age increases, so if a person gets older, that means the probability that they are in the lowest category is increasing. This is consistent with age being negative here. Right? So in this model, what this means is that the older a person gets, the fewer they purchase organic strawberries. Now note that the sum of those effects is equal to 0. What this means is that if a person increases the age by 1 year, then they increase the probability of being in category 1. And if that probability increases, it has to decrease for the other categories as well. The same is true for female. So the 0.098 is, and those 5, and the sum of those 5 values here is going to be negative 0.098. Okay, so the marginal effects here, the sum of the marginal effects for a particular variable are 0. Now, let me illustrate this a bit further, and you can type in b hat dot predict is equal to predict b hat, comma, type equals probs. Now, when you look at the output of this data, what this now tells you is that based on the independent variables of those respondents, note that our original data set had 173 observations. Those predicted probabilities here have, again, 176. Have 173 observations. Note that, for example, 34 here is missing, okay? And so what this means is that based on the independent variables, the model predicts that there's a 47.6% chance that the person is in the 0 category. And there's a 24% chance that the person is in the 1 category. And remember, those categories are never, rarely, once per month, etc. Okay. Now think about this in terms of if you are a supermarket chain and you are interested in how often people are actually purchasing something, then this type of model could help you. Okay. The second type of model that we are going to look at is what is called a multinomial logic. Now, with the ordered logic, we had outcomes, or we had a dependent variable, and there was a natural ordering for this dependent variable. For the multinomial logic, we do not have this natural ordering anymore. So for example, suppose you are interested in a choice of concentrations at the O'Neill School, whether people are going into criminal justice, environmental policy and sustainability, nonprofit management, policy analysis, etc. There is no natural ordering, but this is a choice that students are going to make. Now, before I continue talking about the multinomial logic, there is an issue that comes up very often, and that issue could be solved with more advanced models. Okay? Now, the issue is called independence of irrelevant alternatives, or IIA. Now, let me give you an example. Suppose that you are sitting in a restaurant and you want a dessert, and the waiter comes to the table and says that you have the choice of 2 desserts, either a pie or ice cream. You think a little bit and you decide to go for ice cream. Then the waiter says, "Oh, I forgot, we still have cheesecake for dessert." And then you say, "Okay, in that case, I take the pie." Now, what some of those models suffer is that the number of choices can actually influence the results of what you pick. So when you first pick ice cream over pie, and then you have the third choice of cheesecake, and you're actually switching to pie and not an alternative that was already there before, that would not make sense in reality. So some of those models suffer from this problem, this IIA problem, but we are not going to go into too much details about this in this lecture. Now, what we will see is that when we are looking at multinomial logic models, that this is just one category of models. Because think about the following. You have choices, for example, pie, ice cream, or cheesecake, or what we are going to look at later in this lecture is that you have the choice of purchasing a gasoline vehicle, a hybrid vehicle, and an electric vehicle. Now, there are variables that are specific to the choice. So for example, the purchase price of the car, the fuel efficiency of the car, the maintenance cost of the car. Those are alternative specific variables because those variables are attached to the alternative, to the car, to the choice you make. There are also individual specific variables, And those are variables that are attached to the respondent making the choice. So think back about purchasing a gasoline car, a hybrid car, or an electric car. Then the income or the size of the household, or the whether the person is owning or renting a place, may influence what type of choice the individual makes. And again, those are called individual specific variables. Now, I mentioned before that some of those models come from the consumer choice literature. And so economists differentiate between what are called revealed preferences and stated preferences. Now, revealed preferences are if you actually observe choices made by individual, so where you're tracking their purchases, whereas stated preferences is when you confront consumers with a hypothetical scenario and you ask them what they would do. Now, let us skip the technical aspects of the multinomial logic model and let us just go into the application of those models. Now, I mentioned before that one of the most difficult aspects of those models is to get the data into the right shape. And in a multinomial logic model, we differentiate between two types of shapes, or two types of data setup. One is called a long shape, and the other one is called a wide shape. Now note that if you are interested in the details of those shapes, you can click on the link on this slide and you will get to a PDF called MLogit, which offers a lot of help and explanation about those type of data setups. What those data formats refer to is that in the long shape, you have one row for each alternative. In the wide shape, you have one row for each choice situation. Now, what does that mean? Let us have a look at two data sets, fishing and travel mode. Now, fishing will be in the wide format, where we have 4 fishing modes. Think about tourists deciding how to fish. They can either go to the beach, at the pier, private, or charter. And there will be alternative specific variables. That is the price of the actual alternative. So when you're, for example, renting a boat, and catch is the quantity of fish that you're going to catch. And there will be individual specific variables, which are income. Okay. Now, travel mode is going to be in the long format. So the travel mode refers to a data set that includes the travel mode choices for travel between Sydney and Melbourne. Okay. And you have 4 travel modes: car, air, train, and bus. We will soon see what choice means with yes or no. We have information about the terminal wait time. Note that this is an alternative specific variable. We have a vehicle cost, the travel time, household income, and the party size. Okay. So when you look at those two data sets, okay, then we said that fishing is in the wide format, okay, where we have one row for each choice situation. So in this case, we have the first person, okay, the first person is in the first row, and that person picked charter. And the income of this person was $7,083. Okay. Now, it is very important, and note that all the data sets that you're going to work with are going to be set up that way, is that you have the price of the alternative specific variables or the price is an alternative specific variable, and that it has to be set up such that it's price dot beach, where the beach, pier, boat, and charter has to refer to the mode. Okay, and the same is true for catch. Okay, now the reason why you have to set up the headers of the data in such a way is that R can identify which variables are alternative specific, which is the price and the catch, and this matches the mode, which are here, and which ones are individual specific, which is the income in this case. Now, if you compare this with the travel mode, which is in long format, okay, then you have the first individual. So in the fishing format, you have the first individual in the first row. Now in the long format, you have the first individual in the first 4 rows. Okay, so we have the travel mode. Remember that it was between Melbourne and Sydney. So the first individual had 4 travel modes: air, train, bus, and car. Choice refers to the travel mode the person picked. So individual 1 picked the travel mode car. And now note that we have here the variables, the wait time, the cost, travel, and another variable. Those are individual specific, whereas income and size, those are alternative specific, whereas income and size are individual specific. You see this because they do not change across the individual, right? We have individual 1 who had an income of 35, and the travel size, or the size of the party that traveled, was just 1 person, okay? Whereas the wait time here changes depending on the mode, okay? So again, wait, V cost, travel, and G cost are alternative specific variables attached to the 4 alternatives: air, train, bus, and car. And income and size is associated with the individual. Okay, now in order to estimate those models, we have to let R know how the model is set up, or how the data is actually set up. Now, we said that fishing is in the wide format, where we have 1 row per individual, okay, or per individual respondent. So we have to let R know that that is the case. So we type in fishing equals mlogit data, parenthesis open, fishing, comma, the shape is equal to wide, and then we have to enter the alternative specific variables, and we do this by the term varying. Note that if you type varying, it will tell you that it says the indexes of the variables that are alternative specific, and those are columns 2 through 9. Okay. So if you go back into the data, columns 2 through 9 are alternative specific. And the choice that the individual makes is the mode, which is charter, boat, pier, or beach. We hit enter. And now note, if you look at the data, then R has actually transformed the data into long format, where we have the first individual. The first individual had 4 choices: beach, boat, charter, and pier. And the first individual made the choice of charter. And here we have the income, which is individual specific, and the price and the catch are alternative specific. Note that this is the reason, so that the fact that R can transform the data in such a way to know that price and catch are alternative specific is because we had a very strict rule to describe those variables. Okay. Now, to estimate the model, let us do a very simple model for now, and let us just look at the individual specific variable income and how this actually determines the choice or the mode of fishing. So we type in mlogit, parentheses open, the choice variable or the dependent variable is mode, tilde, and now this becomes important. R, or RStudio, wants to have the alternative specific variables first, then a vertical bar, then the individual specific variables. Now in this case, we do not include the alternative specific variables, so we just put in a 0, then we include a vertical bar, and we say income, and the data is equal to fishing. Now we execute this, and we type summary b hat, and we get the following results. First of all, note that RStudio tells you the frequency of alternatives. So in our case, 11% chose the beach, 35% chose the boat, 38% chose charter, and 15% chose the pier to do fishing. Now, the coefficients reveal that income is statistically significant for those who picked boat and for those who picked charter. Note that one category is missing here, and that is beach. Now, beach in this case is what is called the base category. Those results are relative to the base category beach. So if income increases, a respondent is more likely to switch to renting a boat than going to the beach, or than fishing from the beach. Okay. Now, what you can do is you can also calculate the fitted probabilities. Just call this fishing.fitted is equal to fitted, parentheses open, b hat, and then you have to type in outcome equals false. Now, when you look at the predicted values, what this means, what those represent, are for each individual the probability to fall into one of those categories. So think back about the first individual. So the first individual in reality picked charter, picked the outcome charter. Now our model predicts that that person had a 34% chance of picking charter, and it actually allocated a higher chance of picking the boat. Now, if you compare this now, say, to the second individual, who in reality picked, again, charter, then our model predicted that the person had a 41% chance of actually picking charter. Okay? Now, if you don't like the example about fishing, think back about the choice of products. Now, when you are shopping on Amazon or Target or any other online retailer, then you get products selected. Basically, a little bit more complicated in reality, of course, But basically, those online retailers calculate the probability that you are actually liking a particular product. And if that probability is sufficiently high, then they are suggesting that product to you. So this model is one way. One way of how this can be achieved. Now, let us extend this model by including alternative specific variables. So we are going to copy the model. And note that before the vertical bar, we have the alternative specific variables. So in this case, we are interested in catch and price as the alternative specific variables. So we run the model. And we can see now that we have beach as the base category, and that if there is a higher catch for a particular category, then that increases the probability of switching into that category. The same is true if the price of a particular mode of a particular outcome increases, that reduces the probability of that mode being picked. Note that both of those variables are statistically significant. Very much like before, we can now execute the fitted values. Okay? And we said that for individuals 1 and 2, they both picked charter. Okay? So now when we look at the fitted values, we can still see that the results have changed slightly. Okay? But we still have, for the first 2 individuals, charter has still a very high probability of being picked. Okay? So this is the phishing data set. Now we can also look at a second data set, which is called the travel mode. And very similar to the first data set, we have to let R know how the data set is actually set up. Okay? So in this case, we have to type in travel mode equals mlogit data. The data is travel mode. Choice is equal to column choice. The shape in this case is long. And the alternatives are in the column mode. So when you look at the travel mode here, so we have individual 1. We had air, train, bus, and car as the choices, as the available modes, and the person picked car as the choice. Okay? So we can hit enter, and then we can say b hat equals mlogit, dependent variable is choice, we include 2 alternative specific variables, and we include income and party size as the individual specific variables. And note that we can also define the reference level as the base alternative, That is going to be car. We can say summary b hat. And here we can see that we have a generalized cost measure, we have the wait time, that they are statistically significant, and that means that for an alternative that represents a higher cost or a longer wait time, it decreases the probability that that alternative is picked, is chosen. Note that train, the income, is statistically significant for the variable train, which means that if income goes up, the probability of train being picked, being chosen, is decreasing. Okay. And now note, you can see that although it is not statistically significant, if income increases, then it is more likely that air is going to be picked. But again, this is not statistically significant. Okay. And very much like before, you can calculate the fitted values by typing, say, travel.fitted equals fitted b hat outcome equals false. So now this again represents the probabilities. Note that we have the probabilities all summing up to 100%. So now if we compare, for example, if we take individual 1 and individual 2, individual 1 picked car, and so did individual 2 in order to travel between Melbourne and Sydney. Now, in our model for individual 1 and individual 2, note that the probability associated with car is higher than any other probability in that line. Okay, so here in this case, the model associates a higher probability for the individual based on the income, party size, and also the alternative specific variables, that the person is actually picking the car. Okay. Now, let me demonstrate the last data set. Now, this data set is called EV data, where EV stands for electric vehicle. And this is actually part of a data set that my co-authors and I have used in 2014 to publish a paper about the choice individual makes with regard to purchasing a gasoline vehicle, a hybrid vehicle, a plug-in hybrid vehicle, and an electric car. Okay? Where the choice, so 1 stands for gasoline vehicle, 2 is a hybrid vehicle, 3 is plug-in hybrid, and 4 is an electric car. And we also have data about the age of the respondent, whether they have heard about a level 2 charger. Think about a level 2 charger as a charger that can charge your car in a relatively short amount of time. The number of cars they have. We had information about how much they spent on gasoline. Note that the higher the number, the more they spent. We had information about politics. The higher the number, the more conservative they are. Whether the respondent was female, level of education, and level of income. So again, we have to let R know how the data looks like. Let's just call it EV data equals mlogit data, EV data, comma, shape. Shape is wide. and the choice is equal to choice. And the model that we want to estimate, let's call it B hat, Logit. The dependent variable is choice, and we do not have any alternative specific variables. We're interested in age, female, level 2, the number of cars, education, income, and politics. Now note that the output here is very large. So note that this was a hypothetical choice set, in the sense that we did not observe what respondents actually purchased, but we gave them a hypothetical choice. In this case, 41 or 42% said that they would pick a gasoline car, 26% thought they are going to pick a hybrid car, 22% would pick a plug-in hybrid car, and 9% would pick an electric vehicle. Note that here the base category is the gasoline car. And we see that level 2, or the presence of a level 2, or the knowledge of a level 2 charger, is statistically significant for the plug-in hybrid vehicle and the electric vehicle. This makes sense because both of those vehicles need a charger to be charged. Okay. So here, statistically significant, plus they're positive, meaning that this increases the probability of being in either 3 or category 4 for those two vehicles. Also note that being more conservative, that this decreases to purchase either a hybrid vehicle or a plug-in hybrid vehicle. And this is also statistically significant. Now here again, we can calculate the fitted values by typing in, say EV fitted equals fitted B hat outcome equals false. So note that, for example, the first two individuals both picked individual 1 picked a hybrid, and individual 2 picked a hybrid as well. So when we look at the fitted data, then we see that the model is slightly off because it only associated a 25% and a 30% chance of that individual actually picking a hybrid vehicle. Okay. So this lecture was introducing you to qualitative choice models. Okay.